So lesson 8-2, we're going to talk about how to read a floor plan. We're going to compute the perimeter and the area of a polygon, which you've already done in previous math classes. We're going to compute areas of irregular regions, and we're going to compute volumes of rectangular solids. So, key terms, as always, floor plan. This is a drawing of the layout and the dimensions of a room. So it shows how the floor plan is going to look, and it's going to show the dimensions of each of the rooms in there. Area, this is the space inside 2 dimensions. It is units squared, always measured as units squared, so feet squared, inches squared, meters squared. It's also called the living space of a property. Congruent, you should have heard this before. It's another way of saying equal or having the same length or measurement. Apothem, this is a line segment through the center of a regular polygon that is perpendicular to a side. So we find the center of the polygon and draw a line from the center of that polygon to the side, and it has to be perpendicular through it. Our next key term is perimeter. This is the area, what goes around the edge of the shape. So it's the sum of all the sides. Remember, area is multiplying and perimeter is adding. Monte Carlo method. This is a way of finding the area of an irregular shaped figure by using a proportion. Okay, so we take the number of points inside the region divided by the total number of random points is equal to the area of the irregular polygon divided by the area of a rectangle used to frame the irregular region. So we're going to get into an example of that. It's kind of an interesting way of calculating area. Volume, this is what it takes to fill up something. This is what it holds, the space inside of a 3-dimensional region. For example, a room. Volume is always measured in cubic units. And then British thermal units, or BTUs, this is a unit of measure by which air conditioners are sold, and we're going to get into that in one of our last examples. So how much space do I want? How much space do I need? So what type of apartment would you like when you first move out on your own? What are you looking for? 1 bedroom, 2 bedrooms, a studio? What do you think you want to live in? And then how can houses that have the same floor plan on the inside look different from each other on the outside? So you need to go ahead and finish these 2 questions and answer these on a separate sheet of paper, please. And as we move into our examples, Jerry is using the floor plans for his new home to help him purchase base molding for the place where the walls meet the floor. The plans are drawn using a scale of 1/4 inch represents 1 foot. He measures the walls on the floor plan with a ruler and finds that they total 23.5 inches. If molding costs $2.10 per foot, how much will Jerry spend on molding? So there's 2 pieces here. We need to figure out the conversion factor, so how much he's going to need, and then we have to figure out the total dollar amount here. So we know that 1/4 inch equals 1 foot, and we know that there are 23.5 inches. We need to convert that into feet. So we're going to set up our proportion. So 1/4 inch over a foot, so 1/4 inch is 1 foot. 23.5 inches equals x feet. So we need to cross multiply here. So we end up with 0.25x equals 23.5. We then have to do our division because that's going to undo the 0.25x. So divide both sides by 0.25 and we end up with 94. So Jerry needs 94 feet of molding at $2.10 per foot. What will it cost Jerry to buy the 94 feet of molding? So you need to go ahead and finish that problem. Check your understanding. You need to finish this problem on a separate sheet of paper to be turned in, just like the last one, only this one is still going to be proportion. This time the length of the room is 17 feet. When you use the 1/4 inch scale equals 1 foot, what is the length of the room on the floor plan? So you're going the opposite direction this time. For example 2, Gabriella plans to carpet her living room except for the 1/4 circle shown in the corner. That area will be a wood floor where she will put her piano. The radius of the 1/4 circle is 8 feet. If carpeting costs $9.55 per square foot, what is the cost of the carpeting she will use in her living room? So a couple pieces here we have to do. First, we need to find the area of the room. So go ahead and do that. We know that area is length times width. They give us the dimensions here. It's 25 by 16. So when you multiply 25 by 16, you end up with 400 square feet. Next, we need to find the area of the 1/4 circle. Here's your formula for area of a circle, pi r squared, but we only have 1/4 of it. So I have to take my area here and divide it by 4 or multiply it by 1/4. So when I take pi times 8 squared, so pi times 8 squared, I end up with 64 pi, and then take a quarter of that, so 64 divided by 4, and then multiply that by pi, please. Go ahead and finish this piece here. You should end up with 50.24, okay? And then the next piece would be to subtract out the wood floor to find the area of the carpeted region. So we need to take out the area that we found in part 1 and subtract out what we found in part 2. That'll get us the area of the carpeted piece here. Then they sell it for $9.55 per square feet. So we need to figure out how many square feet of carpet, multiply by $9.55. So you need to go ahead and finish that question. For check your understanding, express the area of this. We're going to actually go ahead and skip that. For example 3, this is the, excuse me, the apothem question. So we have a polygon here. We have an 8-sided figure, which is an octagon. Okay. They need to purchase wood for the floor. It costs $14 per square foot for a special type of wood. Find the cost of the gazebo's floor. Well, we need to do the area formula, which is area equals 1/2 the apothem times the perimeter. Okay. So the apothem here in this case is 12 feet. The perimeter, again, is what it takes to go around the edges. So each edge is 10 feet, and there are 8 of them, so it did 10 times 8. So when you multiply this, you end up with 6 times 80, and you end up with 480 feet squared. So we have 480 square feet of flooring. We need to figure out what is the cost of the gazebo's floor. So you need to finish this, take the square footage, and multiply it by the cost to get your final answer. So please finish this question. Check your understanding. We're going to go ahead and skip this question, so all of these should have skip in your notes. Example 4, Don sculpts out a region for a flower garden as shown. He takes a digital picture of the garden. The irregular polygon would fit inside a rectangle that is 15 by 20 yards. He superimposes a 15 by 20 grid over the photo on his computer. The area of the garden impacts the cost of mulch, plants, fertilizer, and so on. What is the area of the garden? So this is the one where we have to use the Monte Carlo method, which is this big proportion here. Okay, so as I go to example 4 where I have a little bit more room, so here's our picture, and here's some information about this. Don can use probability to find the area. First, he frames the irregular region with a 15 by 20 rectangle, which we did here. Okay, the area of this is 300 square units. He then generates 1,000 random points, so X's and Y's, because as you see here, it's a grid, with a domain from 0 to 20 and a range of the Y's from 0 to 15. So he went from 0 to 20, 0 to 15 here, and generated random points. Now, your calculator has a feature where it will create random numbers for you. Okay? He took all of those random points that the calculator or the computer created for him, and he plotted them and determined that the number of points that landed inside the garden region. So he found that 631 were in here. So he created 1,000 of them. Okay, he created 1,000 data points. 630 of them landed inside this space where the garden is going to go. So we're going to use the following proportion. The number of points inside the region, which he found was 631 after he plotted them, divided by the total number of random points, which was 1,000, so 631 over 1,000, equals the area of the irregular polygon, which was what we're trying to find, so that's X, then divided by the area of the rectangle used to frame the irregular region, which was 300. To solve this problem, you need to cross multiply, so you need to take 631 times 300, and you come up with 189,300 equals 1,000x. So when I take 189,300 and I divide it by 1,000, x equals 189.3. Okay, and again, that's the area inside there, so it's 189.3 units squared. So go ahead and finish that cross multiplication in your notes and show your answer. Check your understanding. This one you need to use the same Monte Carlo, so this is the Monte Carlo method again. Pull out the information here. They tell you the random points. They tell you the number that fall into the irregular figure. You need to find the framed piece, which is 20 by 20 foot square, okay, and then tell me the area of the irregular polygon. So you need to finish this question on a separate sheet of paper to be turned in, please. Example 5, volume, easy. You need to actually do this question. We know that volume is length times width times height, 3 dimensions, it's cubed. So my 3 dimensions, 14 times 6 times 8. Go ahead and calculate the volume, finish this question in your notes. I should see your handwritten multiplication somewhere on your paper here. Check your understanding. We are actually going to skip that question. And example 6, Mike's bedroom measures 16 feet by 14 feet and has a 9-foot ceiling. It is well insulated on the west side of his house. How large of an air conditioner should he purchase? So to calculate a BTU rating, we use the while divided by 60. These each stand for something. I'm sure you can probably figure out what the W, the H, and the L are for, but I bet you don't know what the I and the E are. So let's take a look at them. W is width, H is height, I, this one is new. This is the insulation level, so the insulation rating. If it is well insulated, it gets a 10. If it is poorly insulated, it gets an 18. So the better insulated it is, the lower the value. L is length, and E is the exposure factor, so where the room is based on geography. So is it facing the north, the east, south, or west? And each of those has a different rating because of where the sun shines. So if it's facing north, it's a 16. If it's east, it's facing 17. If it's south, it's 18. And if it's west, it's 20. Okay? So real simple multiplication. To find our BTU rating, we take those values out of here, as well as our exposure and our insulation level, and we put them in, multiply, and divide by 60. So 16 times 14 times 10 times 9 times 20. All of that divided by 60. You should end up, as you finish this problem, end up somewhere around 6,000, almost 7,000. So the estimated air conditioner that he's going to need is probably, you always want to overgo what you need. He should end up with about a 7,000 BTU air conditioner. For the check your understanding, in example 6, find the recommended BTUs if Mike's room was poorly insulated, and the other variables remain the same. So you need to finish this question and turn it in on a separate sheet of paper as well, please. So you're going to go back and you're going to use that BTUs, which equals while divided by 60. And that is all.